The Starry Messenger, sometimes also known as the Sidereal Messenger, as another translation, revealing great, unusual, and remarkable spectacles, opening these to the consideration of every man, and especially of philosophers and astronomers, as observed by Galileo Galilei, gentleman of Florence, professor of mathematics in the University of Padua, with the aid of a spyglass lately invented by him. In the surface of the moon, in innumerable fixed stars, in nebulae, and above all in 4 planets, swiftly revolving about Jupiter at different distances and periods, and known to no one before the author recently perceived them and decided that they should be named the Medicean stars. Venice, 1610. Astronomical Message, which contains and explains recent observations made with the aid of a spyglass concerning the surface of the moon, the Milky Way, nebulous stars, and innumerable fixed stars, as well as 4 planets never before seen, and now named the Medicean stars. Great indeed are the things which in this brief treatise I propose for observation and consideration by all students of nature. I say great because of the excellence of the subject itself, the entirely unexpected and novel character of these things, and finally because of the instrument by which of means they have been revealed to our senses. Surely it is a great thing to increase the numerous host of fixed stars previously visible to the aided vision, adding countless more which have never been seen, exposing these plainly to the eye, in numbers times 10, exceeding the old and familiar stars. It is a very beautiful thing, and most gratifying to the sight, to behold the body of the moon, distant from us almost 60 earthly radii, as if it were no farther away than 2 such measures, so that its diameter appears almost 30 times larger, its surface nearly 900 times, and its volume 27,000 times as large as viewed when with the naked eye. In this way one man learn with all certainty of sense evidence that the moon is not robbed in a smooth and polished surface, but is in fact rough and uneven, covered everywhere, just like the earth's surface, with huge prominences, deep valleys and chasms. Again, it seems to me a matter of no small importance to have ended the dispute about the Milky Way being by making its nature manifest to the very senses as well as to the intellect. Similarly, it will be a pleasant and elegant thing to demonstrate that the nature of those stars which astronomers have previously called nebulous is far from different from what has been believed hitherto. But what surpasses all wonders by far, and what particularly moves us to seek attention of all astronomers and philosophers, is the discovery of 4 wandering stars, not known or observed by any man before us. Like Venus and Mercury, which have their own periods about the sun, these have theirs about a certain star that is conspicuous among the already known, which they sometimes precede and sometimes follow, without ever departing from it beyond certain limits. All these facts were discovered and observed by me not many days ago with the aid of a spyglass which I devised. after first being illuminated by the divine grace. Perhaps other things still more remarkable, with in time will be discovered by me or by other observers with the aid of such an instrument, the form and construct of which I shall briefly explain, as well as the occasion of its having been devised. Afterwards I shall relate the story of observations I have made. About 10 months ago, a report reached my ears that a certain Fleming had constructed a spyglass by means of which visible objects, though very distant from the eye of the observer, were distinctly seen as if nearby. Of this truly remarkable effect several experiences were related, to which some persons gave credence while others denied them. A few days later the report was confirmed to me in a letter from a noble Frenchman at Paris, Jacques Bourdevois, which caused me to apply myself wholeheartedly to inquire into the means by which I might arrive at the invention of a similar instrument. This I did shortly afterwards, my basis being the theory of refraction. First, I prepared a tube of lead, at the ends of which I fitted 2 glass lenses, both plane on one side, while the other side was spherically convex, and the other concave. Then, placing my eye near the concave lens, I perceived objects satisfactorily large and near, for they appeared 3 times closer and 9 times larger than when seen with the naked eye alone. Next, I constructed another one, more accurate, which represented objects as in large more than 60 times. Finally, sparing neither labor nor expense, I succeeded in constructing for myself so excellent an instrument that objects seen by means of it appeared nearly 1,000 times larger, and over 30 times closer than when we regarded with our own natural vision. It would be superfluous to enumerate the number and importance of the advantages of such an instrument at sea as well as on land. But forsaking terrestrial observations, I turned to celestial ones. And first I saw the moon, from as near a hand as if it were scarcely 2 terrestrial radii away. After I observed, often with wondering delight, both the planets and the fixed stars, and since I saw these latter to be very crowded, I began to seek, and eventually found, a method by which I might measure their distances apart. Here it is appropriate to convey certain cautions to all who intend to undertake observations of this sort. For in the first place, it is necessary to prepare quite a perfect telescope, which will show all objects bright, distant, and free from any haziness, while magnifying them at least 400 times, and thus showing them 20 times closer. Unless the instrument is of this kind, it will be vain to attempt to observe all the things which I have seen in the heavens, and which will presently be set forth. Now, in the order to determine without much trouble the magnifying power of an instrument, trace on paper the contour of 2 circles, or 2 squares, of which is 400 times as large as the other, as it will be when the diameter of one is 20 times that of the other. Then, with both these figures attached to the same wall, observe them simultaneously from a distance. looking at the smaller one through the telescope, and at the larger one with the other eye unaided. This may be done so with inconvenience while holding both eyes open at the same time. The two figures will appear to be the same size if the instrument magnifies objects in the desired proportion. Such an instrument having been prepared, we seek a method of measuring distances apart. This we shall accomplish by the following contrivance. Let A, B, C, D be the tube, and E be the eye of the observer. Then, if there were no lenses in the tube, the rays would reach the object FG along the straight lines ECF and also EDG. But when the lenses have been inserted, the rays go along the refracted lines ECH and EDI. Thus, they are brought closer together, and those which were previously directed freely to the object FG now include only the portion of HI. The ratio of the distance EH to the line HI then being found, one may by means of a table of sines determine the size of the angle formed at the eye of the object HI, which we shall find to be but a few minutes of an arc. Now, if to the lens CD we fit thin plates, some pierced with larger, some with smaller apertures, putting now one plate and now another over the lens is required, we may now, at pleasure, different angles subtending more and fewer minutes of arc, and by this means we may easily measure the intervals between stars which are but a few minutes apart, but no greater error than 1 or 2 minutes. And for the present, let it suffice that we have touched lightly on these matters, and scarcely more than mention them, as on the same occasion we shall explain that the entire theory of this instrument. Now let us review the observations made during the past 2 months, once more inviting the attention of all who are eager for true philosophy to the steps of such important contemplations. Let us speak of that surface of the moon which faces us. For greater clarity I distinguish 2 parts of this surface, a lighter and a darker. The lighter part seems to surround and pervade the whole hemisphere, while the darker part discolors the moon's surfaces like a kind of cloud, and makes it appear covered with spots. Now, those spots which are fairly dark and rather large are plain to everyone and have been seen throughout the ages. These I shall call the large or ancient spots, distinguishing them from others that are smaller in size but numerous as to occur all over the lunar surface, and especially the lighter part. The latter spots have never been seen by anyone before. From observations of these spots repeated many times, I have been led to the opinion and conviction that the surface of the moon is not smooth, uniform, and precisely spherical as a great number of philosophers believe, but it is uneven, rough, and full of cavities and prominences, being not unlike the surface of the earth, revealed by chains of mountains and deep valleys. The things I have seen by which I was enabled to draw this conclusion are as follows. On the 4th or 5th day after a new moon, when the moon is seen with brilliant horns, the boundary which divides the dark part from the light
does not extend uniformly in an oval line as would happen on a perfectly spherical solid, but traces out an uneven, rough, and very wavy line as shown in the figure below. Indeed, many luminous excrescences extend beyond the boundary into the darker portion, while on the other hand some darker patches invade the illuminated part. Moreover, a great quantity of small blackish spots, entirely separated from the dark region, are scattered almost all over the area illuminated by the sun, with the exception only of that part which is occupied by the large and ancient spots. Let us note, however, that the said small spots always agree in having their blackened parts directed towards the sun, while the side opposite the sun they are crowned with bright contours, like shining summits. There is a similar sight on earth about sunrise, when we behold the valleys not yet flooded with the light through the mountains surrounding them, are already ablaze with the glowing splendor on the side opposite the sun. And just as the shadows in the hollows on earth diminish in size as the sun rises higher, so do these spots on the moon lose their blackness as the illuminated region grows larger and larger. Again, not only are the boundaries of shadow and light in the moon seen to be uneven and wavy, but still more astonishingly, many more bright points appear within the darkened portion of the moon, completely divided and separated from the illuminated part and at a considerable distance from it. After a time, these gradually increase in size and brightness, and an hour or two later they become joined with the rest of the lighted part, which has now increased in size. Meanwhile, more and more peaks shoot up as if sprouting now here, now there, lighting up within the shadowed portion. These become larger, and finally they too are united with that same luminous surface which extends ever further. An illustration of this is to be seen in the figure above, and on the earth, before the rising sun, are not the highest peaks of the mountains illuminated by the sun's rays while the plains remain in shadow? Does not the light go on spreading while the larger central parts of those mountains are becoming illuminated? And when the sun has finally risen, does not the illumination of plains and hills finally become one? But on the moon, the variety of elevations and depressions appears to surpass in every way the roughness of terrestrial surface, as we should demonstrate further on. At present, I cannot pass over in silence something worthy of consideration, which I have observed when the moon was approaching first quarter, as shown in the previous figure. In the luminous part there extended a great dark gulf in the neighborhood of the lower cusp. When I have observed it for a long time and had seen it completely dark, a bright peak began to emerge, a little below its center, after about 2 hours. Gradually growing, this presented itself in a triangular shape, remaining completely detached and separated from the lighted surface. Around it, 3 other small points soon began to shine, and finally, when the moon was about to set, this triangular shape, which had meanwhile become more widely extended, joined with the rest of the illuminated region and suddenly burst into the gulf of shadow like a vast promontory of light, surrounded still by the 3 bright peaks already mentioned. Beyond the ends of the cusps, both above and below, certain bright points began to emerge which were quite detached from the remaining lighted part, as may have been seen depicted in the same figure. There were also a great number of dark spots in both the horns, especially in the lower one. Those nearest the boundary of light and shadow appeared larger and darker, while those more distant from the boundary were not so dark and distant. But in all cases, as we have mentioned earlier, the blackish portion of each spot is turned toward the source of the sun's radiance, while a bright rim surrounds the spot on the side away from the sun, in the direction of the shadowy region of the moon. This part of the moon's surface, where it is spotted as the tail of a peacock is sprinkled with azure eyes, resembles those glass vases which have been plunged while still hot in cold water, and have thus acquired a cracked and wavy surface, from which they'll receive their common name of ice cups. As to the large and lunar spots, these are not seen to be broken in the above manner and full of cavities and prominences. Rather, they are even and uniform, and brighter patches crop up only here and there. Hence, if anyone wished to receive the old Pythagorean opinion that the moon is like another earth, its brighter part might very fitly represent the surface of the land, and its darker region that of water. I have never doubted that if our globe were seen from afar when flooded with sunlight, the land regions would appear brighter and the watery regions darker. For large spots in the moon are also seen to be less elevated than the brighter tracts. For whether the moon is waxing or waning, there are always seen, here and there along its boundary of light and shadow, certain ridges of brighter hue around the larger spots, and we have attained to this in the preparing the diagrams. The edges of these spots are not only lower, but also more uniform, being uninterrupted by peaks or ruggedness. Near the large spots, the brighter part stands out particularly in such a way that before the first quarter and toward the last quarter, in the vicinity of a certain spot in the upper or northern region of the moon, some vast prominences arise both above and below, as shown in the figures reproduced. Before last quarter, this same spot is seen to be walled about with certain blacker contours, which, like the loftiest mountain tops, appear darker on the side away from the sun and brighter on that which faces the sun. This is the opposite of what happens in the cavities, for there the part away from the sun appears brilliant, while that which is turned toward the sun is dark and in shadow. After a time, when the lighted portion of the moon's surface has diminished in size, and when all, or nearly all, the said spot is covered with shadow, the brighter ridges of the mountains gradually emerge from the shade. This double aspect of the spot is illustrated in the ensuing figures.
There is another thing which I must not omit, for I beheld it not without a certain wonder. This is that almost in the center of the moon there is a cavity larger than all of the rest, and perfectly round in shape. I have observed it near both first and last quarters. I have tried to represent it as closely as possible in a second image of the above figures. As to light and shade, it offers the same appearance as would a region like Bohemia, if that it were enclosed on all sides by very lofty mountains, arranged exactly in a circle. Indeed, this area on the moon is surrounded by such enormous peaks that the bounding edge adjacent to the dark portion of the moon is seen to be bathed in sunlight before the boundary of light and shadow reaches halfway across the same space. As in other spots, its shaded portion faces the sun, while its lighted part is toward the dark side of the moon. And for a third time I draw attention to this as very cogent proof of the ruggedness and unevenness that pervades all the bright region of the moon. Of these spots, moreover, there always seems to be the darkest which touch the boundary line between light and shadow, while those further off appear both smaller and less dark, so that when the moon ultimately becomes full at opposition to the sun, the shade of the cavities is distinguished from the light of the places in relief by a subdued and very tenuous separation. The things we have reviewed are to be seen in the brighter region of the moon. In the larger spots, no such contrast of depressions and prominences is perceived as that which we are compelled to recognize in the brighter parts by the changes of aspect that occur, varying illumination by the sun's rays through the multiplicity of positions from which the latter reach the moon. In the large spots there exist some holes rather darker than the rest, as we have shown in the illustrations. Yet these present always the same appearance, and their darkness is neither intensified nor diminished, although with some minute difference there appears sometimes a little more shaded and sometimes a little lighter according as the rays of the sun fall on them more or less obliquely. Moreover, they join with neighboring regions of the spots in a gentile linkage, the boundaries mixing and mingling. It is quite different with the spots which occupy the brighter surface of the moon. These, like precipitous crags, having rough and jagged peaks, stand out starkly in sharp contrast of light and shade. And inside the large spots there are observed certain other zones that are brighter, some of them very bright indeed. Still, both these and the darker parts present always the same appearance. There is no change either of shape or of light and shadow. Hence, one may affirm beyond any doubt that they owe their appearance to some real dissimilarity of parts. They cannot be attributed merely to irregularity of shape, wherein shadows move in consequence of varied illuminations from the sun, as indeed is the case with the other, smaller, spots which occupy the brighter part of the moon and which change, grow, shrink, or disappear from one day to the next, as owing their origin only to shadows of prominences. But here I foresee that many persons will be assailed by uncertainty, and draw into a grave difficulty, feeling constrained to doubt a conclusion already explained and confirmed by many phenomena. If that part of the lunar surface which reflects sunlight more brightly is full of chasms, that is, of countless prominences and hollows, why is it that the western edge of the waxing moon, the eastern edge of the waning moon, and the entire periphery of the full moon are not seen to be uneven, rough, and wavy? On the contrary, they look as precisely round as if they were drawn with a compass, and yet the whole periphery consists of that brighter lunar substance which we have declared to be filled with heights and chasms. In fact, not a single one of the great spots extends to the extreme periphery of the moon, but all are grouped together at a distance from the edge. Now let me explain the twofold reason for this troublesome fact, and in turn give a double solution to the difficulty. In the first place, if the protuberances and cavities in the lunar body existed only along the extreme edge of the circular periphery bounding the visible hemisphere, the moon might, indeed would necessarily, look to us almost like a toothed wheel, terminated by watery and wavy edge. Imagine, however, that there is not a single series of prominences arranged only along the very circumference, but a great many ranges of mountains together, with their valleys and canyons disposed in ranks near the edge of the moon, and not only in the hemisphere visible to us, but everywhere near the boundary line of the two hemispheres. Then, an eye viewing them from afar will not be able to detect a separation of prominences by cavities, because the intervals between the mountains located in a given circle or a given chain will be hidden by the interposition of heights situated in yet other ranges. This will be especially true if the eye of the observer is placed in the same straight line with the summits of these elevations. Thus, on Earth, the summits of several mountains close together appear to be situated in one plane if the spectator is a long way off and is placed at an equal elevation. Similarly, in a rough sea the tops of waves seem to lie in one plane, though between one high crest and another there are many gulfs and chasms of such depth as not only to hide the hulls, but even the bulwarks, masts, and rigging of stately ships. Now, since there are many chains of mountains and chasms on the moon in addition to those around its periphery, and since the eye, regarding these from a great distance, lies nearly in the plane of their summits, no one need wonder that they appear as arranged in a regular and unbroken line. To the explanation just given may be added, namely, that there exists around the body of the moon, just as around the earth, a globe of some substance denser than the rest of the ether. This may serve to receive and reflect the sun's radiations without being sufficiently opaque to prevent our seeing through it, especially when it is not illuminated. Such a globe, lighted by the sun's rays, makes the body of the moon appear larger than it really is, and if it were thicker than it would be able to prevent our seeing the actual body of the moon. And it actually is thicker near the circumference of the moon. I do not mean in an absolute sense, but relatively to the rays of our vision, which cut it obliquely there. Thus it may obstruct our vision, especially when it is lighted, and cloak the lunar periphery that is exposed to the sun. This may be more clearly understood from the figure below, in which the body of the moon, A, B, C, is surrounded by the vaporous globe, DEG. The eyesight from F reaches the moon in the central region. At A, for example, through a lesser thickness of the vapors, dA, while toward the extreme edges a deeper stratum of vapors, EB, limits and shuts our sight. One indication of this is that the illuminated portion of the moon appears to be larger in circumference than the rest of the orb, which lies in shadow, and perhaps this is the same cause will appeal to some as reasonably explaining why the larger spots on the moon are nowhere seen to reach the very edge, probable though it is that some should occur there. Possibly they are invisible by being hidden under a thicker and more luminous mass of vapors. That the lighter surface of the moon is everywhere dotted with protuberances and gaps has, I think, been made sufficiently clear from the appearances already explained. It remains for me to speak of their dimensions, and to show that the Earth's irregularities are far less than those of the moon. I mean that they are absolutely less, and not merely in relation to the sizes of the respected globe. This is plainly demonstrated as follows. I have often observed in various situations of the moon with respect to the sun, that some summits within the shadowy portion appeared lighted, though lying some distance from the boundary of the light. By comparing this separation to the whole diameter of the moon,
I found that it sometimes exceeded 1/20th of the diameter. Accordingly, let CAF be a great circle of the lunar body, E its center, and CF a diameter, which is to the diameter of the earth as 2 is to 7. Since according to a very precise observations the diameter of the earth is 7,000 miles, CF will be 2,000, CE 1,000, and 1/20th of CF will be 100 miles. Now let CF be the diameter of the great circle, which divides the light part of the moon from the dark part, for because of the very great distance of the sun from the moon, this does not differ appreciably from the great circle. And let A be distant from C by 1/20th of this. Draw the radius EA, which, when produced, cuts the tangent line GCD, representing the illuminating ray. In the point D, then the arc CA, or rather the straight line CD, will consist of 100 units, whereof CE contains 1,000, and the sum of the squares of DC and CE will be 1,010,000. This is equal to the square of DE. Hence, ED will exceed 1004, and AD will be more than 4 of those units, of which CE contains 1000. Therefore, the altitude AD on the moon, which represents a summit reaching up the solar ray GCD and standing at the distance CD from C, exceeds 4 miles. But on Earth we have no mountains which reach a perpendicular height of even 1 mile. Hence, it is quite clear that the prominences on the moon are loftier than those on Earth.
Here I wish to assign the cause of another lunar phenomenon well worthy of notice. I have observed this not just recently, but many years ago, and pointed it out to some friends and pupils, explaining it to them and giving its true cause. Yet since it is rendered more evident and easier to observe with the aid of the telescope, I think it is not unsuitable for instruction in this place, especially as it shows more clearly the connection between the moon and the earth. When the moon is not far from the sun, just before or after new moon, its globe offers itself to view not only on the side where it is adorned with shining horns, but a certain faint light is also seen to mark out the periphery of the dark part which faces away from the sun, separating this from the darker background of the ether. Now, if we examine the matter more closely, we shall see that not only does the extreme limb of the shaded side glow with this uncertain light, but the entire face of the moon, including the side which does not receive the glare of the sun, is whitened by a not inconsiderable gleam. At first glance, only a thin luminous circumference appears, contrasting with a darker sky coterminous with it. The rest of the surface appears darker from its contact with the shining horns which distract our vision. But if we place ourselves so as to interpose a roof or chimney or some other object at a considerable distance from the eye, the shining horns may be hidden while the rest of the lunar globe remains exposed to view. It is then found that this region of the moon, though deprived of sunlight, also shines not a little. The effect is heightened if the gloom of the night has already deepened through departure of the sun. For in a darker field, a given light appears brighter. Moreover, it is found that this secondary light of the moon, so to speak, is greater according as the moon is closer to the sun. It diminishes more and more as the moon recedes from that body until, after the first quarter and before the last, it is seen very weakly and uncertainly even when observed in the darkest sky. But when the moon is within 60 degrees of the sun, it shines remarkably, even in twilight, so brightly indeed that with the aid of a good telescope one may distinguish the large spots. This remarkable gleam has offered no small perplexity to philosophers, and in order to assign a cause for it, some have offered one idea and some another. Some would say it is inherent and natural light of the moon's own, others that it is imparted by Venus, others yet by all the stars together, and still others derive it from the sun, whose rays they would have permeate the thick solidity of the moon. But statements of this sort are refuted, and their falsity evinced with a little difficulty. For if this kind of light were the moon's own, or were contributed by the stars, the moon would retain it, and would display it particularly during eclipses, when it is left in an unusual dark sky. This is contradicted by experience, for the brightness which is seen on the moon during eclipses is much fainter and is ruddy, almost copper-colored, while this is brighter and whitish. Moreover, the other light is variable and movable, for it covers the face of the moon in such a way that the place near the edge of the earth's shadow is always seen to be brighter than that of the rest of the moon. This undoubtedly results from the contact of a tangent solar rays with some denser zone which girds the moon about. By this contact a sort of twilight is diffused over the neighboring regions of the moon, just as on earth a sort of crepuscular light is spread both morning and evening. But with this I shall deal more fully in my book on the system of the world. To assert that the moon's secondary light is imparted by Venus is so childish as to deserve no reply. Who is so ignorant as to not understand that from new moon to a separation of 60 degrees between moon and sun, no part of the moon which is averted from the sun can possibly be seen from Venus? And it is likewise unthinkable that its light should depend on the sun's rays penetrating the thick solid mass of the moon, for then this light would never dwindle, inasmuch as one hemisphere of the moon is always illuminated except during lunar eclipses. And the light does diminish as the moon approaches first quarter, becoming completely obscured after that is past. Now, since the secondary light does not inherently belong to the moon, and is not received from any star or from the sun, and since in the whole universe there is no other body left but earth, what must we conclude? What is to be proposed? Surely we must assert that the lunar body, or any other dark and sunless orb, is illuminated by the earth. Yet what is there so remarkable about this? The earth, in fair and grateful exchange, pays back to the moon an illuminating similar to that which it receives from her throughout nearly all the darkest gloom of night. Let us explain this matter more fully. At conjunction, the moon occupies a position between the sun and the earth. It is then illuminated by the sun's rays on the side which is turned away from the earth. The other hemisphere, which faces the earth, is covered with darkness. Hence, the moon does not illuminate the surface of earth at all. Next, departing gradually from the sun, the moon comes to be lighted partly upon the side it turns toward us, and its whitish horns, still very thin, illuminate the earth with a faint light. The sun's illumination of the moon increasing now as the moon approaches first quarter, a reflection of that light to earth also increases. Soon the splendor on the moon extends into a semicircle, and our nights grow bigger. At length the entire visible face of the moon is irradiated by the sun's resplendent rays, and at the full moon the whole surface of the earth shines in a flood of moonlight. Now the moon, waning, sends us her beams more weakly, and the earth is less strongly lighted. At length the moon returns to conjunction with the sun, and black night covers the earth. In this monthly period, then, The moonlight gives us alterations of brighter and fainter illumination, and the benefit is repaid by the earth in an equal measure. For while the moon is between us and the sun, at new moon, there lies before it the entire surface of that hemisphere of the whole earth, which is exposed to the sun and illuminated by vivid rays. The moon receives the light which this reflects, and thus the nearer hemisphere of the moon, that is, the one deprived of sunlight, appears to have the virtue of this illumination to be not a little luminous. When the moon is 90 degrees away from the sun, it sees but half of the earth illuminated, the western half. For the other side, the eastern half, is enveloped in night. Hence the moon itself is illuminated less brightly from the earth, and as a result its secondary light appears fainter to us. When the moon is in opposition to the sun, it faces a hemisphere of the earth that is steeped in the gloom of night. And if this position occurs in the plane of the ecliptic, the moon will receive no light at all, being deprived of both the solar and the terrestrial rays. In its various other positions with respect to the earth and sun, the moon receives more or less light according as it faces a greater or smaller portion of the illuminated hemisphere of the earth. And between these two globes a relation is maintained such that whenever the earth is most brightly lighted by the moon is least lighted by the earth, and vice versa. Let these few remarks suffice us here concerning this matter, which will be more fully treated in our system of the world. In that book, by a multitude of arguments and experiences, the solar reflection from earth will be shown to be quite real against those who argue that the earth must be excluded from the dancing whirl of stars, for that specific reason that it is devoid of motion and of light. We shall prove the earth to be a wandering body surpassing moon in a splendor, and not worth the sink of all dull refuse of the universe. This we shall support by an infinite argument that's drawn from nature. Thus, we have spoken of our observations concerning the body of the moon. Let us now set forth briefly what has thus been observed regarding the fixed stars. And first of all, the following fact deserves consideration. The stars, whether being fixed or wandering, appear not to be enlarged by the telescope in the same proportion as that which it magnifies other objects, and even the moon itself. In the stars this enlargement seems to be so much less that the telescope, which is sufficiently powerful to magnify other objects 100-fold, is scarcely able to enlarge the stars 4 or 5 times. The reason for this is as follows. When stars are viewed by means of unaided natural vision, they present themselves to us not as of their simple and, so to speak, their physical size, but as irradiated by a certain fulgor, and is fringed with sparkling rays, especially when the night is far advanced. From this they appear larger than they would appear if stripped of those advantageous airs of light. For the angle at the eye is determined not only by the primary body of the star, but by the brightness which extends so widely about it. This appears quite clearly from the fact that when stars first emerge from twilight at sunset they look very small, even if they are of the first magnitude. Venus itself, when visible in broad daylight, is so small as scarcely to appear equal to a star of the 6th magnitude. Things fall out differently with other objects, and even with the moon itself. These, whether seen in daylight or the deepest night, appear always of the same bulk. Therefore, the stars are seen crowned among shadows, while daylight is able to remove their headgear, and not daylight alone, but any thin cloud that interposes itself between a star and the eye of the observer. The same effect is produced by black veils or colored glasses, through the interposition of which obstacles the stars are abandoned by their surrounding brilliance. A telescope similarly accomplishes the same result. It removes the stars, their advantageous and accidental rays, and then it enlarges their simple globes, if indeed the stars are naturally globular, so that they seem to be magnified in a lesser ratio than other objects. In fact, a star of the fifth or sixth magnitude, when seen through a telescope, presents itself as one of the first magnitude. Deserving of notice also is the difference between the appearances of the planets and the fixed stars. The planets show their globes perfectly round and definitely bounded, looking like little moons, spherical and flooded all over with light. The fixed stars are never seen to be bounded by a circular periphery, but have rather the aspect of blazes whose rays vibrate about them and scintillate a great deal. Viewed with a telescope, they appear of a shape similar to which they present to the naked eye, but sufficiently enlarged so that the star of the fifth or sixth magnitude seems equal to the dog star, largest of all the fixed stars. Now, in addition to the stars of the sixth magnitude, a host of other stars are perceived through the telescope which escape the naked eye. These are so numerous as almost to surpass belief. One may, in fact, see more of them than all the stars included amongst the first six magnitudes. The largest of these, which we may call the stars of the seventh magnitude, or the first magnitude of invisible stars, appear through the telescope as larger and brighter than stars of the second magnitude when the latter are viewed with the naked eye. In order to give one two proofs of their almost inconceivable number, I have adjoined pictures of two constellations. With these as samples, you may judge all the others. In the first, I had intended to depict the entire constellation of Orion, but I was overwhelmed by the vast quantity of stars and by limitations of time, so I have deferred this to another occasion. There are more than 500 new stars distributed among the old ones within the limits of 1 or 2 degrees of arc. Hence, to the 3 stars in the belt of Orion, and the 6 in the sword, which we previously known, I have added 8 adjacent stars discovered recently, preserving the intervals between them as exactly as I could. To distinguish the known or ancient stars, I have depicted them larger, and have outlined them doubtly. The other, invisible stars, I have drawn smaller, and without the extra line. I have also preserved differences of magnitude as well as possible. Third, I have observed the nature of the material of the Milky Way. With the aid of the telescope, this has been scrutinized so directly and with such ocular certainty that all the disputes which have been vexed by philosophers through so many images have been resolved, and we are at last freed from wordy debates about it. The galaxy is, in fact, nothing but a congeries of innumerable stars grouped together in clusters. Upon whatever part of the telescope it is directed, a vast crowd of stars is immediately presented to view. Many of them are rather large and quite bright, while a number of smaller ones is quite beyond calculation. But it is not only in the Milky Way that whitish clouds are seen. Several patches of similar aspect shine with faint light here and there through the ether, and if the telescope is turned upon any of these, it confronts us with a tight mass of stars. And what is even more remarkable, the stars which have been called nebulous by every astronomer up to this time turn out to be groups of very small stars arranged in a wonderful manner. Although each star separately escapes our sight on account of its smallness or immense distance from us, the mingling of their rays gives rise to that gleam which was formerly believed to be some denser part of the ether that was capable of reflecting rays from the stars or from the sun. I have observed some of these constellations and have decided to depict 2 of them. In the first you have the nebula called the Head of Orion, in which I have counted 21 stars. The second contains the nebula called, which is not a jingle star, but a mass of more than 40 starlets. Of these I have shown 36, in addition to the ocelli, arranged in the order shown. We have now briefly recounted the observations made thus far with regard to the Moon, the fixed stars, and the Milky Way. There remains the matter which in my opinion deserves to be considered the most important of all, the disclosure of 4 planets, never seen from the creation of the world up to our own time, together with the occasion of my having discovered and studied them, their arrangements, and the observations made of their movements and alterations during the past 2 months. I invite all astronomers to apply themselves to examine them, and determine ere periodic times, something which had so far been quite impossible to complete, owing to the shortness of time. Once more, however, warning is given that it will be necessary to have very accurate telescopes, such as we have described at the beginning of this discourse. On the 7th day of January in this present year of 1610, at the first hour of night, when I was viewing the heavenly bodies with a telescope, Jupiter presented itself to me, and because I had prepared very excellent instrument for myself, I perceived, as I had not before on account of the weakness of my previous instrument, that besides the planet there were 3 starlets, small indeed, but very bright. Though I believed them to be among the host of fixed stars, they aroused my curiosity somewhat by appearing to lie in an exact straight line parallel to the ecliptic, and by their being more splendid than the others of their size. Their arrangement with respect to Jupiter and each other was the following. That is, there were 2 stars on the eastern side and 1 to the west. The most easterly star and the western one appeared larger than the other. I paid no attention to the distances between them and Jupiter, for at the outset I thought them to be fixed stars, as I have said. But returning to the same investigation on January 8th, led by what? I do not know, I found a very different arrangement. The 3 starlets were now all to the west of Jupiter, closer together, and at equal intervals from one another, as shown in the following sketch. Time, though I did not yet turn my attention to the way the stars had come together, I began to concern myself with the question how Jupiter could be east of all these stars, when on the previous day it had been west of the 2 of them. I commenced to wonder whether Jupiter was not moving eastward at that time, contrary to the computations of the astronomers, and had got in front of them by that notion. Hence, it was with great interest that I awaited the next night, but I was disappointed in my hopes, for the sky was then covered with clouds everywhere. On the 10th of January, however, the stars appeared in this position with respect to Jupiter. That is, there were but 2 of them, both easterly, the third, as I suppose, being hidden behind Jupiter. As a fact, they were in the same straight line with Jupiter and were arranged precisely in the line of the zodiac. Noticing this, and knowing that there was no way in which such alterations could be attributed to Jupiter's motion, yet being certain these were still the same stars I had observed, in fact, no other was to be found along the line of the zodiac for a long way on either side of Jupiter. My perplexity was now transformed into amazement. I was sure that the apparent changes belonged not to Jupiter but to the observed stars, and I resolved to pursue this investigation with greater care and attention. And thus, on the 11th of January, I saw the following disposition. There were 2 stars, both to the east, the central one being 3 times as far from Jupiter as from the one farther east. The latter star was nearly double the size of the former, whereas on the night before they had appeared approximately equal. I had now decided beyond all question that there existed in the heavens 3 stars wandering about Jupiter as do Venus and Mercury about the sun, and This became plainer in daylight from observations on similar occasions which followed. Nor were there just 3 such stars. 4 wanderers complete the revolutions of Jupiter, and of their alterations as observed more precisely later, as we shall give a description here. Also, I measured the distances between them by means of the telescope, using the method explained prior. Moreover, I recorded the times of the observations, especially when more than one was being made during the same night, for the revolutions of these planets are so speedily completed that it is usually possible to take even their hourly variations. Thus, on the 12th of January, at the first hour of night, I saw the stars arranged in this way. The most easterly star was larger than the western one, though both were easily visible and quite bright. Each was about 2 minutes of arc distant from Jupiter. The third star was invisible from the first, but commenced to appear after 2 hours. It almost touched Jupiter on the east, and was quite small. All were on the same straight line directed along the ecliptic. On the 13th of January, 4 stars were seen before me for the first time, in this situation relative to Jupiter. 3 were westerly and 1 was to the east. They formed a straight line, except that the middle western star departed slightly towards the north. The eastern star was 2 minutes of arc away from Jupiter, and the intervals of the rest from one another from Jupiter were about 1 minute. All the stars appeared to be of the same magnitude, and though small were very bright, much brighter than the fixed stars of the same size. In the first hour of night, there were only 2 stars. One was to the east, 10 minutes from Jupiter, the other to the west, 6 minutes away. The eastern one was somewhat smaller than the western one, but at the 5th hour the 3 stars were seen. In addition to the 2 already noticed, a third was discovered to the west, near Jupiter. It had at first been hidden behind Jupiter, and was now 1 minute away. The eastern one appeared farther away than before, being 11 minutes from Jupiter. This night, for the first time, I wanted to observe the process of Jupiter and its accompanying planets through the line of the zodiac in relation to some fixed star, and such a star was seen to the east, 11 minutes distance from the easterly starlet, and a little removed toward the south, in the following manner. On the 27th of February, 4 minutes after the first hour, the stars appeared in this configuration. The most easterly was 10 minutes from Jupiter, the next 30 seconds. The next to the west was 2 minutes 30 seconds from Jupiter, and the most westernly was 1 minute from that. Those nearest Jupiter appear very small, while the ones were plainly visible, especially the westernmost. They marked out an exactly straight line along the course of the ecliptic. The process of these planets toward the east is seen quite clearly by a reference to the fixed star mentioned, since Jupiter and its accompanying planets were closer to it, as may be seen in the figure above. At the 5th hour, the eastern star closer to Jupiter was 1 minute away. At the first hour, on February 28th, 2 stars were only seen, one easterly, distant 9 minutes from Jupiter, and one to the west, 2 minutes away. They were easily visible and on the same straight line. The fixed star, perpendicular to this line, now fell under the eastern planet as is seen in this figure. And the 5th hour, a third star, 2 minutes east of Jupiter, was seen in this position. On the 1st of March, 40 minutes after sunset, 4 stars, all to the east, were seen, of which the nearest to Jupiter was 2 minutes away. The next was 1 minute away from this. The third, 2 seconds from that, and brighter than any of the others. From this, in turn, the most easterly was hour minutes distant, and was smaller than the rest. They marked out almost a straight line, but the third one, counting from Jupiter, was a little to the north. The fixed star formed an equilateral triangle with Jupiter and the most easterly star, as in this figure. On March 2nd, half hour after sunset, there were 3 planets, 2 to the east and 1 to the west, in this configuration. The most easterly was 7 minutes from Jupiter and 30 seconds from its neighbor. The western was 2 minutes away from Jupiter. The end stars were very bright and were larger than that in the middle. They appeared very small. The most easterly star appeared a little elevated toward the north from the straight line through the other planets in Jupiter. The fixed star previously mentioned was 8 minutes from the western planet along the line drawn from its perpendicular to the straight line through all the planets, as shown above. I have reported these relations of Jupiter and its companions with the fixed star so that anyone may comprehend that the progress of those planets, both in longitude and latitude, agrees exactly with the movements derived from the planetary tables. Such are the observations concerning the 4 Medicean planets recently discovered by me, and although from these data their periods have not been reconstructed in numerical form, it is legitimate at least to put in evidence some facts are worthy of note. Above all, since they sometimes follow and sometimes precede Jupiter by the same intervals, and they remain within very limited distance either to the east or west of Jupiter, accompanying that planet in both retrograde and direct movements in a constant manner, no one can doubt that they compete their revolutions about Jupiter and at the same time affect altogether a 12-year period about the center of the universe. That they also revolve in unequal circles is manifestly deduced from the fact that the greatest elongation from Jupiter, it is never possible to see these planets in conjunction, whereas in the vicinity of Jupiter they are found united, 2, 3, and sometimes all 4 together. It is also observed that the revolutions are swifter in those planets which describe smaller circles about Jupiter, since the stars closest to Jupiter are usually seen to the east, when on the previous day they appear to the west, and vice versa, while the planets which trace the largest orbit appears upon accurate observation of its returns to have a semi-monthly period. Here we have a fine and elegant argument for quieting the doubts of those who, while accepting the tranquil mind the revolutions of the planets about the sun in the Copernican system, are mightily disturbed to have the moon alone revolve around the earth and accompanying it in annual rotation about the sun. Some have believed that this structure of the universe should be rejected as impossible, but now we have not just one planet rotating about another, while both run through a great orbit around the sun. Our own eyes show us 4 stars which wander around Jupiter, as does the moon around Earth, while altogether trace out a grand revolution about the sun in the space of 12 years. And finally, we should not omit the reason for which the Medicean stars appear sometimes to be twice as large as at other times. Though their orbits and Jupiter are very restricted, we certainly cannot seek the cause in terrestrial vapors, as Jupiter and its neighboring fixed stars are not seen to change in size in the least while this increase in diminution are taking place. It is quite unthinkable that the cause of variation should be their change of distance from the Earth at perigee and apogee, since a small circular rotation could by no means produce this effect. In oval motion, which in this case would have to be nearly straight, seems unthinkable and quite inconsistent with the appearances. But I shall gladly explain what occurs to me on this matter, offering it freely to the judgment and criticism of thoughtful men. It is known that the interposition of terrestrial vapors make the sun and moon appear large, while the fixed stars and planets are made to appear smaller. Thus, The two great luminaries are seen larger when close to the horizon, while the stars appear smaller and for the most part hardly visible. Hence the stars appear very feeble and by day and in twilight, though the moon does not, as we have said. Now, from what has been said above, and even more from what we shall say at great length in our system, it follows that not only the earth, but also the moon is surrounded by an envelope of vapors, and we may apply precisely the same judgment as to the rest of the planets. Hence, it does not appear entirely impossible to assume that around Jupiter also there exists an envelope denser than the rest of the ether, but which the Medicean planets revolve, as does the moon about the elemental sphere. Through the interposition of this envelope, they appear larger, and they are in perigee with by the removal, or at least the attenuation of this envelope. Time prevents my proceeding further, but the gentle reader may expect more soon. Finis.